Computers today are doing something that used to be strictly reserved for humans. They are teaching themselves. For a long time, getting a machine to perform a task meant writing out every logical step in painstaking detail. Humans provided every rule. These punch cards were those rules in physical form. Every hole represented a precise command that the machine had to follow exactly. But imagine trying to write a rule for what a dog looks like. You'd have to describe every breed, every angle, and every possible lighting condition. The list of rules would never end. So we flipped the process. Instead of writing the list ourselves, we show the machine thousands of examples and let it deduce the rules for itself. This method works for almost anything: detecting diseases in medical scans, translating speech in real time, or navigating a car through traffic. Because it can learn to solve nearly any problem given enough data, it is becoming a utility that powers our modern world, much like electricity. There are two main ways a machine learns from that data. The first is supervised learning, which is like giving the computer a cheat sheet with all the right answers. It's similar to studying with flashcards. We show the machine an image and tell it, "This is a dog." Then we show it another and say, "This is not." It studies these patterns to recognize a dog in a photo it has never seen. But sometimes we have mountains of data and no labels at all. We don't have a cheat sheet, and we don't even know what categories we're looking for. This is unsupervised learning. We ask the machine to find similarities on its own. It organizes the chaos into distinct groups, based on patterns we might not even notice. Deliberate, while supervised learning trains a computer to identify things we already know about, unsupervised learning helps it discover the hidden organization within messy data. To process these complex patterns, we use a digital circuit inspired by the way our own brains work, a neural network. Information enters an input layer on the left, passes through a hidden layer, and produces a prediction at the output. The connection links are key. Each has a weight, an adjustable volume dial, where signals are amplified or turned down. These volume dials work together to transform the incoming data. The final combination of signals determines the output, like calculating a 90% probability that an image contains a specific object. Because these dials control the final result, the machine's intelligence is stored entirely in the settings of these adjustable links. When a neural network starts, those volume dials are set to completely random numbers. Its very first predictions are just wild guesses. To learn, the network takes a guess, checks the correct answer, and measures how far off it was. These numerical values represent the size of that error. This leads to a process called backpropagation. The network sends that error information backward through the layers to see which specific dials caused the mistake. It splits the blame. Dials that contributed most to the error get adjusted the most, while others are left alone. It's a mathematical way of fine-tuning the circuit. The network does this millions of times. Guess, check, and adjust. The network achieves its accuracy through a persistent cycle of practice. It refines its own internal circuitry one small correction at a time. We moved from writing rigid rules to feeding machines data. We use layered networks to process that data and backpropagation to fix mistakes. AI teaches itself by spotting patterns and constantly rewiring its own internal settings. Warm. Thanks for watching. See you next time.